So Micheal is a senior consultant specialising in air quality with Katestone Global. Micheal's background is in energy biosystems engineering from UCD, with subsequently a PhD in the whole area of odour measurement, abatement, dispersal modelling, also from UCD. He's been a senior consultant with Katestone since 2013, and Katestone is an Australian-based company established in 1989 with its office primarily based in Brisbane, Queensland, with the second branch in Ireland, which is headed up by Micheal. In 2023, Erbia completed a project with Katestone Global on air emissions from biomass used at industrial agricultural sites, and that's how we got to know Micheal. He's found knowledge and a very technically proficient in his work, and we look forward to Micheal just presenting today his presentation around some of the regulatory requirements and the air quality requirements associated with the biomass sector. So Micheal, over to you. 20 minutes. We're under pressure for time, so if you could pull that forward a small bit, we'd appreciate it too. So thanks very much.
Thanks very much, Sean, and thanks Sean and Noel for inviting me to speak today. So as Sean mentioned, I work for Katestone Environmental, and we deal predominantly with air quality impact assessment, climate change assessment and odour. And I suppose the reason, one aspect of the installation of biomass, or the use of biomass for industrial heat, is decarbonisation, but one of the main concerns, I suppose, as part of regulatory planning and licensing applications is the potential impact on air quality, not just for biomass, but for... Okay, that's not... Yeah, I'm fine. Yeah. Yeah, as I said, one of the main issues is air quality, because any source of combustion, whether it is fossil fuel or biomass or renewable fuels, will be that there are emissions to the atmosphere, and the potential effects that these have on whether it's human health or ecological health or any entity that needs to be protected. So briefly, Katestone is it's based in Brisbane. It's made up of two companies. The consultancy side of things, where we do the regulatory applications, is Katestone Environmental. We also have a sister company called Weather Intelligence. So predominantly that is associated with the development of apps and tools that use weather data anywhere where weather forecasting can be used to make decisions, and intelligent management solutions. That side of the company deals with that. So very quickly today, we'll be looking at, what I'll be discussing is, what I'll be talking about today is air quality regulatory considerations if you are putting in a biomass boiler. And the two things that will be of concern are limitations on the concentrations of emissions in the stack, and the second thing is the impact of those emissions on the surrounding environment. So these are two requirements that are covered under various European directives for in-stack concentrations and for ambient concentrations. The two of them are linked, but they are quite different, and the assessment of them are different. So predominantly for the various European directives that underpin the in-stack concentrations would be the medium combustion plant, large combustion plant and eco-design directives. And within that, these deal with combustion installations of various sizes, and they provide emission, within those directives, they provide emission limit values that have to be achieved for these installations in the stacks through which emissions are exhausted. So I'll just focus very quickly on the medium combustion plant directive. Essentially, it's for existing and new medium combustion plants that are required to comply with specific emission limit values. These emission limit values for new medium combustion plants, they represent emission levels that are readily achievable from modern, well-operated combustion plants. They're not setting limits that are quite difficult to achieve with new technologies. These are technologies that achieve these emission levels readily. And its aims are obviously to limit the emissions across Europe, and I suppose the image that you see on the screen are the ambient levels of nitrogen dioxide across Europe, predominantly the highest level of impacts occurring across cities and populated areas. The second thing would be to limit impacts on human health. Now obviously if you stop a large amount of emissions, if you reduce emissions, you're going to improve or you're going to limit impacts on human health, vegetation and biodiversity. And I suppose the third thing that the medium combustion plant, it's not stated explicitly, but compliance with the medium combustion plant ensures that plants are serviced and maintained in the long run to achieve those emission limit values, that you don't start off with a piece of equipment that works well and ultimately let it fall into disrepair or to operate in a way that doesn't meet the emission limit value requirements. And the emission limit values specified in these directives, they do not guarantee adherence with the limit specified for ambient air in other directives. And the limits for the protection of human health and ecosystems are specified in different European directives, predominantly the CAFE directive and the fourth daughter directive of the Air Quality Framework from 1996, which is yet to be incorporated into the Clean Air for Europe directive, the CAFE directive. So specifically on that, just a quick example is that when you're looking at the in-stack limits versus the limits in the environment, the emission limit value for a biomass installation, it's quite small, it's circled in red there, is 300 milligrams per normalized cubic meter of NOx. And the ambient air quality limit for NOx specified in the CAFE directive is 30 micrograms, which is 10,000 times lower. So the ambient limit is obviously is substantially more stringent than the in-stack limit, and the atmosphere provides the mechanism to advect and diffuse the emissions in-stack to levels that comply with the CAFE directive. And again, these are readily achievable for a large number of plants across Europe. And the mechanism by which we determine if there is sufficient levels of advection and diffusion of these pollutants to adhere to the CAFE directive requirements is done through dispersion modelling. So that's the tool that we use day in, day out to do these assessments and to demonstrate to the regulator, whether it be planning or whether it be EPA through licensing, that emission limit or the ambient air limits can be achieved. So very quickly, I'll talk about the requirements for the legislation, directives and regulations that underpin the requirement for air quality assessment. It's predominantly required through the Planning and Development Act, and within the Planning and Development Act, it refers to the requirement for environmental impact screening for a whole range of whether it's impacts on air, water, land. We focus on the impacts on air quality, and if screening shows that there are the potential for effects, you're required to, as part of the planning or licensing process, to undertake an environmental impact assessment report, and the modelling fits into the air quality chapter of that report. There's also an increasing requirement for air quality assessment as part of appropriate assessment, whether that be screening or Natura impact statement. Appropriate assessment is looking at potential impacts on sensitive nature sites across Europe. And while historically impact assessment is focused on human health, we're seeing an increasing need for regulatory approvals around and assessment around Natura impact or Natura impact statements and on ecologically sensitive sites. And in general, councils will look for air quality assessments generally required. It's to determine the effect on the environment which the development would have, and we use the dispersion modelling tool for that. Specifically in relation to the EIA directive, it's the Environmental Impact Assessment Directive. There are specific thresholds that determine whether an assessment is required, and certainly a full EIA report is required if your heat output is greater than 300 megawatts. And then that's under Annex 1. Under Annex 2, industrial installations for the production of electricity, steam and hot water come under that, under Annex 2 of the Environmental Impact Assessment Directive. And industrial installations carrying gas, steam, hot water, transmission and electrical energy by overhead cables, these are required to, may be required by a regulator to undertake an EIAR assessment, and the air quality assessment fits into that. There is also for installations that aren't directly producing energy for the national network, I suppose, other licensable activities that require a license that also require combustion on site. So, for example, pharmaceutical, large-scale pharmaceutical, the food industry. These type of installations will generate electricity on site. And as part of a new license application, you will be required, or you may be required to demonstrate that the combustion sources on site will not cause adverse air quality impacts beyond the site boundary. And generally, once a license is issued, there is a requirement in the license that if you are changing fuel type or if you are changing emission sources, that there would be a requirement to complete an EIAR and demonstrate that air quality issue, demonstrate that the whole range of environmental impacts will be insignificant. And when you're dealing with combustion sources, predominantly the impact is that's assessed as on air quality. So I very quickly look at just discuss the dispersion modelling tools that we use. These are dispersion modelling tools rely on, they're very similar to meteorological models that we see on that are used for weather forecasts. There's different levels of approaches that can be used. You can assume that the weather conditions at a specific location are represented by, say, a weather station on the Met Air network, or we can run forecasts specific to an area to determine what weather patterns occur at that area, and then within those weather patterns, we would look at we would determine where and how plumes move and disperse, and what level of impacts are caused. The modelling is quite technical. It's very, very mathematically based, and a lot of the work we do is just number crunching day in, day out. But I'll try and give a bit of an indication here about what that looks like in practice. The guidance that we use, and that's specified, it's probably difficult to see here, is specified by the Environmental Protection Agency. Air modelling guidance is, the technical document is AG4, and it gives, I suppose the overview here gives an indication of the different levels of models that can be used to assess air quality impacts. We can use screening models, we can use site representative models, and we can use site-specific models. And these are all approved in accordance with this chart by EPA. As Sean alluded to, we have developed a screening model for IRBIA for the installation of small-scale biomass boilers on intensive agricultural sites, predominantly poultry, and that has been rolled out a number of years ago, and a number of applications have been approved through that for impacts on air quality through that screening tool. The screening tool, however, is quite conservative. It's not applicable to every type of, to every installation, and in those instances we need to do more site-specific work through modelling, local meteorology, local emissions to demonstrate that impacts won't be caused beyond the site boundary. And I suppose as you move into the more detailed models, there's two types of models that can be used. One is the steady-state Gaussian plume, and that assumes that meteorology is uniform across the modelling domain. And it's a again, there's elements of conservatism built into it to account for the fact that the atmosphere is three-dimensional, and it does, atmospheric conditions and weather conditions vary from location to location. But that's, I suppose, when you're using conservative approaches, it overcomes the limitations of the steady-state models. And predominantly where we're moving to is non-steady-state Gaussian puff models, which take into account the variance of meteorology across modelling domains. I'll just give you a few visual images of this to kind of take into account, to demonstrate that the advanced models are actually warranted, that it's not all just completely, I suppose, theoretical pie in the sky, as some people have said to me in the past. So some of the more advanced models, what we're looking at here is a temperature inversion. the advanced models provide, essentially what happens here is because the ground is cooler than the air above it, you get a layer of cool air which is trapped by a layer of warm air that sits above it, and within that pollutants are limited with vertical dispersion. And the more advanced models provide a better characterization of this, and that is used for provide a better representation and are therefore slightly less conservative as part of the assessment process. And then again, the three-dimensional nature of the atmosphere, you can see here in this image where emissions from the plume initially at vector 1 are blown by the wind in one direction, but ultimately the winds and low-level winds in the valley take it and move it in a different direction. And if your installation is in an area where complex meteorology like this, for example, terrain or close to the coast, these sort of effects should be taken into account. And again, our assessments are done on a site-specific, as-needed basis. And just closer to home, I suppose, these are images from Mount Leinster, from gorse fires on Mount Leinster, and again, it just shows that in certain instances, more advanced models are required in order to undertake the air quality impact assessment and demonstrate to the regulators that your installation won't cause adverse air quality impacts. And there's just a few, again, another image around that. So predominantly our assessment takes the form of, you look at your industrial plant and you input that into a model which would include buildings, your sources in the centre, and you run, you essentially determine what effects of all these things wouldn't the calculations have on receptors in the vicinity of the site. You can see the receptor grid here. It can be set up as flat terrain, depending if you've got complex terrain, you can bring that into the models. We generally, when a client approaches, we will discuss these sort of things with them and determine the most appropriate approach. And finally, as I said, an increasing concern recently has been on the impact of on Natura 2000 sites, and I'm going to specifically from combustion sources, the deposition of nitrogen exhausted from plume or from stacks on ecosystems. And in Ireland, the most sensitive ecosystems are peat bogs. And essentially what happens is, with excessive nitrogen deposition, you're getting changes in plant species that occur on the bog, or you're prohibiting the growth of lichens and bryophytes that actually underpin the development of the bog and actually soak in carbon. So this is something that is of concern, and it's certainly something that is being requested more and more as part of the applications that we are doing. So pretty much that's it. I hope that gives you some indication of the kind of the work that's done. It's apart from the carbon reduction element of the rollout of biomass, air quality assessment would seem to be the number 2 consideration that is looked at by that requires assessment by the regulators. So that's it. Thank you very much.